Hello there, this is a video for Algebra 2. It is the second part of 3.1, so 3.1b. We are still solving systems of equations. However, our method for solving today will be substitution and elimination. So in example 1, we're going to get started with three different types of substitution, if you will. And I want to tell you that the goal when you're doing substitution is to replace into one of the equations, one of the variables with the second equation. Okay? Now when you do this, it doesn't matter which variable you choose. I can choose x or I can choose y. However, in some cases, there is typically an easier method. For example, suppose that I wanted to choose to solve for x, because in order to use substitution, one of the equations that you're given has to be solved for one of the variables. In other words, you can have an equation like this, but your second equation should say x equals something or y equals something. And we don't have that in either of these equations. So our first goal, is to get one of those equations solved for a variable. And I did say a variable, it doesn't matter which variable. But let's say that I wanted to solve for x. In the first equation, if I choose to take the first equation and solve for x, I will have to subtract 3y and divide by 4, which will cause me to have a fraction. Which is not bad, it's just that it causes more problems along the way. We all know how much you guys don't like fractions. And so it just makes it more complicated. If I choose y, I'm in the same boat. If I subtract 4x and divide by 3, I'm going to get a fraction again. So I don't want to choose the first equation in this case. And then I go to the second equation and I say, okay, well, what if I choose x? Well, then I have to add the y and divide by 2 and again, fraction. The only variable here that I can solve for that will result in not having a fraction is for me to choose the variable y. And the reason for that, and so that you know in the future going forward, you want to look for a variable that has a coefficient of 1, and preferably that it's positive. In this case, we don't have that, but in part B, you can see that of the two equations, the second equation has both variables with a coefficient of 1, and both variables are positive. So in this case, it wouldn't matter if I chose x or y, but I should choose equation 2 as opposed to equation 1. But in part A, we are going to choose to solve for y. So that means that what I have to do is subtract 2x from both sides. And then, or actually, we can do that a little bit easier. Let me, fewer steps here. I am going to add the y, back to my pen, add the y to both sides. When I do that, I get 2x equals y plus 7. Then I can move the 7 over, and I will get y equals 2x minus 7. All right? So that is the first part, is to get one of the equations solved for a letter, for a variable. In this case, we chose to solve for y. Okay, so what I'm saying here is that the second equation, 2x minus y equals 7, is the exact same thing as 2x minus 7 equals y. And now, as we learned in the previous lesson, when you solve a system, the only way for the system to work is for the x and y coordinate to be the same for both equations. And so since we know that they have to be the same for both of these equations, what I can do now is take my first equation, don't go back to the second one, you already solved for the second one, go back to the first equation and replace or substitute the y variable for what we just solved y to be 2x minus 7. So since y equals 2x minus 7, I'm going to replace the y in the first equation with 2x minus 7, and that's why we call this substitution. And now all I have to do is solve for x. So I get 4x plus 3 times 2 is 6x, 3 times negative 7, negative 21, equals 4. 4x and 6x is 10x, minus 21 equals 4. Add 21 to both sides, and that gives me 10x equals 25. Divide by 10, and x equals 5 goes into 25 5 times, and 5 goes into 10 2 times, so I get 5 halves, or 2.5, but we should leave it as a fraction 5 halves. Now, to solve for y, we know that y equals 2 times x minus 7. And since we just figured out that x is 5 halves, we can replace the x variable in our simplified equation here. We can replace the x variable with 5 halves and solve. So 2 times 5 is 10. 10 divided by 2 is 5. Or basically the 2's cancel. And you get 5 minus 7, which means that y equals negative 2. At the very end, we should always write our solution as an ordered pair, just like we did in the previous section where x goes first. So 5 halves, comma, negative 2, and this would be our solution. So that, in a nutshell, is how we do substitution. But I again want to just do a couple more, just in case you're still not quite sure. So in part B, like I said before, we have the option of choosing x or y as the variable to solve for. And just to be different from the first one, I'm going to go ahead and choose to solve for x. So I am going to subtract y from both sides, and I get that x is equivalent to negative y minus 12. Okay? So now that we know that, we can go back to the original equation, which is right here, and say 2 times x minus 3y equals 6. So I'm just rewriting the same equation, but instead of x, I'm going to replace x with negative y minus 12. Okay? And then I'm going to continue to solve, just like we did in the last one. So we're going to get 2 times negative y is negative 2y. 2 times negative 12 is negative 24. Minus 3y equals 6. And negative 2y and negative 3y combines to negative 5y. Minus 24 equals 6. We add 24 to both sides. And we get negative 5y equals 24 and 6, which is 30. We divide by negative 5. And we get that y equals negative 6. Once we have figured out what y is, we come back to our x, and x equals negative y minus 12. And since we just learned that y equals negative 6, we replace that there. And then negative times negative is positive 6 minus 12, and so then x also equals negative 6. And then the last step is to write our answer as an ordered pair. X coordinate going first, y coordinate going second. In this case, it doesn't really matter because they're the same coordinate. So there you go, and that's how you do that. So do one last example for substitution real quick, and that's this guy right here. Believe it or not, I wanted to do this because oftentimes people think this is really hard, and it's really not. And this is part C. It's in your textbook. It's got a whole word problem that goes along with it. But it says Alejandro has a computer support business. He estimates that the cost to run his business can be represented by y equals 48x plus 500. So there's the first equation. Where x is the number of customers, he also estimates that his income can be represented by y equals 65x minus 145. There's our second equation. And it says, how many customers will Alejandro need in order to break even? What will his profit be if he has 60 customers? So there's two parts to this question. But basically what we have here is a cost equation, and we have a income equation. So one of these equations represents how much he's spending, and this one is how much he's making. And he wants to know when he's going to break even, so he wants to know when they're going to equal each other. But we can actually solve this by using substitution, because we know that y equals this, and at the same time y equals this. And since y has to equal itself, even though this is actually very simple to do, a lot of times students will confuse it. Y has to equal y, which means that 48x plus 500 has to equal 65x minus 145. So basically what happens in this case is that both equations are already solved for y, And so all we have to do is make them equal each other and then continue as normal. So I'm going to subtract 48x, subtract 48x. It's going to give me 500 equals 65 minus 48, which is 17x minus 145. Then we're going to add the 145 to both sides. And 17x is going to equal 645. Divide that by 17, and x equals 37.9, roughly. Now here's a dilemma. That is exactly how many customers Alejandro will need in order for his cost to equal his income. However, we can't really talk about 37.9 customers because that would mean that one of our customers is missing some limbs or something. But no, we can just round it up to 38. So to answer the question, Alejandro would need 38 customers before he would be able to break even. The second part of the question is asking what will his profit be if he has 60 customers. Now remember, the profit equation was the second equation. So if he had 60 customers, we're just going to go ahead and take our second equation, which is our profit. This was cost. This was income or profit. So we're going to take what if y equals 65. What if he had 60 customers? How much income would he have? And we're going to solve that little guy, and then we'll be done with this example. Okay, so 60 times 65 is 3,900 minus 145, and so the profit would be $3,755, which was the second part of the question that they were asking us there. All right, so okay, so that's how much income he would have. I'm sorry, I call that profit. I shouldn't have done that. This is how much income he'll get, but we also need to know what his cost is. So the cost would be y equals 48 times 60 plus 500, like that. So we're going to 48 times 60, which is 2880, plus 500, which gives you a cost of $3,380. So with 60 customers, it's going to cost him $3,380, but he's going to be making $3,755. So the way that we describe profit is your income minus your cost. So 3,755 minus 3,380, which brings us to 3,755 minus 3,380. $375 of actual profit. Alrighty, so that in a nutshell is how you do elimination. And we have one other or two other examples. Hopefully these will go by a little bit faster. I want to check on my time here. I hope this video does not go into a second video, but I'll try to do as fast as I can and to be thorough at the same time. So what is happening here is elimination, and this is supposed to be some kind of a review. So elimination is basically when you take two equations and you add them together, and when you add them together, one of the variables will eliminate. And, oh, I'm sorry, this is your do-it-yourself question. Sorry, we need to keep going here to elimination. So again, we're going to have three equations, but like I was saying, you want to, when you use elimination, you want to add the two equations together, and one of the variables should cancel or eliminate, which is why we call it elimination. So again, the goal here is to get one of the variables to have the same coefficient with opposite signs. Okay? So for example, here's the x variable. We have a 4 coefficient and a 1 coefficient. They're not the same number. They're not both 4. And they're not opposite sign. They're both positive. We need one to be positive, one to be negative. So our first example is the easiest case when it's already done for you. Because although the x doesn't work, the y does. And again, it doesn't matter which variable you choose as long as you pick the one that's the easiest. And again, you could choose x, but it would just be more work. So we want to go the easiest route. So the easiest route is going to be to pick y, because one is negative, one is positive, and they're both 2's. So now all we have to do in this case is to add the two equations together. And when we do that, they're actually going to cancel on their own. So 4x plus 1x is 5x. Negative 2y plus 2y is going to cancel, hence eliminate, and 7 plus 3 is 10. We then divide by 5, and x equals 2. Now at this point, we go back to our previous system, which is substitution. And so we say that it doesn't matter which equation you pick, you just pick one and plug in the x. So I'm going to say 4 times x minus 2y equals 7. Since we know that x is 2, we are going to now solve. 4 times 2 is 8, minus 2y equals 7. Subtract the 8 from both sides. Negative 2y equals negative 1. Divide by negative 2, and y will equal positive 1/2. Our last step, of course, is to write the answer in ordered pair, as an ordered pair. X is 2, y is 1/2. And there you go. That is your elimination for you. Again, this was the easiest of the two examples. So then we're going to go to part B. And in part B, it's not going to be as easy as part A. I look at the x variables, and they both have the same coefficient. They're both 1. But again, they're both positive. We want one to be positive, one to be negative. For the y case, again, they're both positive, and this is a 2, that's a 1. So in this case, I would think that the x variable is easier to solve for, or easier to eliminate, because in order to get this to eliminate, I need a negative 2y, a positive 2y, and a negative 2y. So I need to multiply this equation by a negative 2 to get a negative 2y, or I need to multiply by negative 1 to get a negative x and a positive x. So I'm going to go ahead and choose the easier, which is just negative 1. And so this equation will now be rewritten, and it's now going to actually be negative 1 times x will be negative x. Negative 1 times positive y is negative y, and negative 1 times 6 is negative 6. That's the part where most people get messed up, where they don't multiply by the constant. You need to multiply all three things by this number. Okay, the top equation stays the same. It's still x plus 2y equals 10. And then I'm going to add them together, like I did in the previous example. And like the previous example, the positive x and the negatives will cancel. And 2y minus 1y will leave you with 1y. And 10 minus 6 is 4. So the y is 4. And now once we find the first variable, we can just plug it in to get the second variable. So I'm going to say x plus 2 times y equals 10. Since we know that y equals 4, we can plug that in and we get x plus 8 equals 10. Subtract 8 from both sides. And now we get that x equals 2. Our last step, of course, is to write the answer as an ordered pair. X is 2, y is 4. So just to recap, in the first example, there was no multiplying of equations to be done because they were already opposites. In part B, we had to multiply one of the equations by something to get the opposites. And now in part C, we're going to have to multiply both equations by something to get opposites. In other words, in part C, we've got 3m and 5m, not the same number, and they're not multiples of each other, so I can't times this by something and be done. We have 4 and 6, same idea. So in this case, we're actually going to have to multiply both equations by something. So I'm going to take the top equation and multiply it by negative 5, and the bottom equation and multiply it by positive 3. And the reason for that is because I want to get negative 5 times 3m is going to be negative 15, and 5 times positive 3 will be positive 15. And that is how I'm planning to eliminate the m variable. So let's do that. So this is going to be 3 times negative 5, negative 15m. 4 times negative 5 is negative 20n. And negative 13 times negative 5 is positive 65. On the bottom we have 5m times positive 3 is positive 15m. 6 times 3 is positive 18n. And then negative 19 times 3 is going to be negative 57. Okay? So once I've got my both equations multiplied by something, I can now add the two equations together. The negative 15 positive, we're going to cancel. Negative 20n plus 18n is negative 2n. And 65 minus 57 is going to equal 8. Divide by negative 2, and n equals negative 4. And now that we know what n is, we can go back and solve for m. And in this case, I don't want to pick these equations and plug it into because they're bigger numbers. I'm going to go back to the original equation, which is 3m plus 4 times n equals negative 13. I'm going to replace it with negative 4. And we're going to have 3m minus 16 equals negative 13. Then we add 16 to both sides. And 3m equals 16 minus 13, which is 3. Divide by 3, and m equals 1. Our last step is to write them as an ordered pair. And this is not x and y, but whenever you write them as an ordered pair, you should write them in an alphabetical order. So m comes before n. So m will be 1 and n negative 4. And there is my solution. And that is how you do elimination. Okay, our last example, and I'm going to once again check my time here, just make sure I'm okay. Yep, we have a little bit more time. And so our last example is here. And it says solve each system by substitution or elimination. But more importantly, what I want you to gather from these examples is that, like we had in the graphing scenario, it is possible to have inconsistent systems, and it's possible to have consistent systems that are dependent and independent. So in this case, I want to show you a consistent system that's dependent and an inconsistent system, and what that would look like in the case of substitution, all right, or in the case of elimination. So it doesn't really matter how you solve it, but it does matter what their answer is going to end up being. Okay, so here we go. We are going to solve this little guy, and so what's going to happen is, for example, I see that the x is negative and positive, so is the y, so it doesn't matter which one I pick, but I'm just going to go ahead and go with x, and I multiply the equation by I'm sorry, I don't want to do that. I want to multiply the top equation by a 2, because by doing that, I am going to get negative 6x. Negative 3 times 2 is negative 6x plus 10y equals 14. And then I'm going to add that to the bottom equation, which is 6x minus 10y equals negative 14. And you can kind of already see what's happening here. When I add these two equations together, not only did I eliminate the x variable, but by default, I also eliminated the y variable. So 0 equals 14 minus 14 is 0. Since this is always true, this is a case of the lines being the same exact line. So this is basically a system that is consistent and dependent, and thus you have infinite solutions. Any number will work in this case. You have infinite number of solutions, and any number will work. Okay? So then part B is very similar in nature. In part B, I do the same thing. I'm trying to figure out how I can get this going. So I multiply the top equation by a 3, and the bottom equation maybe by a negative 2. And again, the reason for that is to get the variables to cancel. By doing that, I will get negative 2 times 3 is negative 6x. 3 times 4 is 12. And 6 times 3 is 18. On the bottom, I get negative 2 times negative 3 is positive 6x. Negative 2 times 6y is negative 12y. And then 8 times negative 2 is negative 16. So in this case, when I add the two equations together, again, the x is canceled. the y's canceled, so 0 equals 18 minus 16, which is 2, and this is never true. 0 does not ever equal 2. So that's never true. These are parallel lines. That's why that happened. So this system is inconsistent. And furthermore, there is no solution. So I just wanted to show you what that would look like if you weren't graphing it. This is what parallel lines would look like. You'd get a false statement. And in the case of the same line, you'd get a statement that is always true. Okay, so now you're going to try this little guy. And I want to tell you that we also forgot to give you the do-it-yourself for elimination. So the do-it-yourself for elimination is actually right here. So this is the do-it-yourself number 2, and here's the do-it-yourself number 3. And once you've done that, you will have completed the notes for this lesson, and I will see you in class, and thank you for watching.